All right, let's take a look at section 6.6. So we're going to be solving more log equations in exponential. So first thing is we have to think about the domain. We talked about this before, but the domain of a log function, that parenthesis part, remember, has to be greater than 0. We talked about that in the last unit. So the domain has to be greater than 0. And again, what we're talking about is the input that's in the parentheses of the log. So for example, this one, the input is x. So the domain is going to be x is greater than 0. There's no work to solve for that one. That one is just what it is. Now we're actually going to find out what x is. X has to be greater than 0 or we have to throw out the answer. So what we're going to go ahead and do is isolate the log. So I'm going to divide by 6 to both sides. That's going to give me log base 4 of x equals 2. Whenever you're stuck in log form, you're going to go ahead and change it to exponential. So we're going to isolate the log and then change to exponential. And that's what it says right here. If one log, you want to isolate the log and then change to exponential form and solve. So isolated, solving now, 4 squared is equal to x. 4 squared is 16. Then you have to check, is 16 greater than 0? Yes, it is. So we will keep our solution as x equals 16. Let's take a look at part B. Same idea, that input has to be greater than 0. So let's start with the domain part. So for the domain, we're going to say x squared minus 6x is greater. Oops, I'm going to do all my inputs in blue just to be organized. So we've got x squared minus 6x is greater than 0. I can solve this one because it's a quadratic. This is when I said go ahead and use your calculator to make it a little bit easier on you so you can graphically see what you're looking at. This is a graph that looks like this. It crosses the x-axis at 0 and at 6. So when we're talking about greater than 0, that's when it's above the x-axis. So those two parts. So our domain for this is when x is less than 0 or x is greater than 6. That's our domain. So we're going to answer that part first. And now we're going to go ahead and now solve the log. The nice thing is the log is isolated. Notice that there's nothing else by it. I can't solve it, so I'm going to turn it into exponential. So 2 to the 4th equals x squared minus 6x. 2 to the 4th is 16. So to solve this, it's a quadratic. I'm going to get it equal to 0 by subtracting 16 to both sides. I'm going to go ahead and factor this. Two numbers that multiply to negative 16 and add to negative 6 are negative 8 and positive 2. And then when I go ahead and solve that, that gives me x equals 8 and x equals negative 2. And then I want to ask myself, are those solutions? X equals 8 would be somewhere over here, so yes. X equals negative 2 would be somewhere over here, so yes, because it falls under this. X is greater than 6, 8 is greater than 6, or x is less than 0. Negative 2 is less than 0. So both of these are solutions. We do not have to throw one out. I will show you an example of where we do throw out one of the solutions next. Okay, the next two examples are if there's multiple logs. So let's take a look. If there's multiple logs, you're going to go ahead and simplify, and you're going to use the power rule to eliminate coefficients. You're going to combine the logs and then change to exponential form. So your goal really is to get one log by using your rules and then go ahead and change form. So shorthand, that's kind of what you're doing. So right now, notice that we have two logs. So we want to go ahead and get it into one log. So the first thing I'm going to do is I'm going to swing this 2 and make it an exponent. So I've got log base 2 of 4 plus log base 2. I can go ahead again and swing that. So that's going to be x minus 6 squared equals 4. Now notice, because I am adding here, that means what I can do with my 4, and my x minus 6 squared is I can turn that into multiplying to write it with 1 log. So that turns into 4 times x minus 6 squared. So that's all of your input equals 4. Now I've got 1 log. I'm going to go ahead and convert to exponential. So this is 2 to the 4th equals 4 times x minus 6 squared. And I'm just going to go ahead and solve this here. So it's just a lot of algebra work now. 2 to the 4th is 16. Remember, x minus 6 squared is really foiling. So it's x minus 6 times x minus 6. So when I FOIL it, I'm going to get x squared minus 12x plus 36. Put my work up here. Now I'm going to have to go ahead and distribute that, that 4. So I'm going to have 16 equals 4x. Actually, I could divide by 4 to everything. I'll do that on the next step. So now I'm going to go ahead and divide everything by 4 because I'm noticing that they're all able to be divided by 4. I could have done that in the last step, but that's okay. Which gives me 4 equals x squared minus 3x plus 12, not plus 12, plus 9. 36 divided by 4 is 9. Now I'm going to set it equal to 0 by subtracting 4. 9 minus 4 is going to give me a positive 5. Wait, I'm just noticing something. When I distributed the 4, I only distributed it to one number. I did not distribute it to the negative 12 and the 36. So I'm actually going to erase my work here. And to make it easier, let's just go ahead and divide by 4 in this step. So then I don't have to worry about multiplying 4 times 12 and 4 times 36. So let's go ahead and divide by 4 here. 16 divided by 4 is 4. And then I'm left with x squared minus 12x plus 36. Those don't change because the 4 over 4 cancel on the right side, okay? Now I'm going to go ahead and subtract 4. Way easier to do it that way so I don't have to deal with larger numbers. Now I'm going to factor it because it's a quadratic. 2 numbers that multiply to 32 and then add to negative 12 is going to be negative 8 and negative 4. So when I solve that, I get x equals 8 and x equals 4. Okay, so now I have to check that with the domain. So we haven't done the domain yet, so now I'm going to go ahead and do the domain here. So the domain is the input is greater than 0. So we have x, and I guess I don't even need that much room. The domain is x minus 6, that's the input, is greater than 0. And when I solve that, that means x is greater than 6. So any value where x is greater than 6 works. Notice x equals 8 does work. Notice x equals 4 does not work. You need to throw that answer away by crossing it out. It is not a solution. All right, let's take a look at the next one. It doesn't really matter if you solve for the domain first or second. I'm going to go ahead and just solve the log first. Notice there's 2 logs again. I want to get it to be 1 log. I want to condense it into 1 log. They're both log base 1/8. And this time we're subtracting. So remember, when you're subtracting, that means you're going to take this and you're going to divide it by this. So you can turn it into 1 log using division. And it equals 1. Now I'm going to go ahead and I'm going to convert it into exponential form. So my base is 1/8. My exponent here is 1 equals x squared plus x over x squared minus x. Remember, 1/8 to the first is just 1/8. So I'm going to go ahead and just save some room and take away the 1 because anything to the first means it doesn't change. Then I'm going to go ahead and I'm going to cross multiply to solve this. So I'm going to get 1 times x squared minus x, that doesn't change. And then 8 times x squared plus x, and that's 8x squared plus 8x. I'm going to go ahead and move everything to one side. So that's going to get me 7x squared plus 9x. And then I'm going to continue to factor that. I can take out an x, which leaves me with 7x plus 9, which means x is going to be 0. And if I solve that one, negative 9 over 7. I just set each factor equal to 0. The domain. The domain is the input is greater than 0. We have really two domains going on. So for the domain, you have to say x squared plus x is greater than 0. And you have x squared minus x is greater than 0. So I'm just going to go ahead and graph both of those on the same picture. So it's going to look like this and like this. So it has to be true for both of them. So we've always talked about highlighting above. So this is above and this is above the x-axis. And you might try to highlight those two, but you can't highlight those two because that is not above for both equations, okay? So it's just going to be the two outer. It's going to be x is less than, oops, I didn't put what that value is. When you graph it, you're going to find out that this is -1 and this is +1. It's just going to always be the two outside arms that are going out. So your domain is going to be x is less than -1 or x is greater than 1. Otherwise, because of the arrows, it would actually end up pretty much being all real numbers, which it's not. It's only the two outside arms so that it falls under both of those inequalities. So then you check your numbers, x equals 0. Is x equals 0 less than -1 or greater than 1? No, so we're going to throw that answer out. -9/7 is about here. And that is going to be in our highlighted part. It's less than -1, so that is a solution. So sometimes you will have to throw an answer out. Okay, let's keep going. We're going to go ahead and solve when there's logs on each side. So what you can do is if you have logs on each side, you can drop the logs and solve as long as you have isolated the log. So it's isolate log and drop the logs and solve. So for instance, in this case, it's not isolated because we have that 2 in the front there. So we're going to go ahead and swing that 2 to be an exponent. So log base 9 of x squared. Same thing with this negative. We're going to swing it to become an exponent. So that's going to become a -1. And now, because we have logs on each side, now you can go ahead and cancel the same log base 9. So we're going to have x squared is equal to 81 to the -1st. And 81 to the -1st, remember, is just 1 over 81. So if you're going to solve for x, you're going to square root both sides. So x is going to be plus minus 1 over 9. Square root of 1 over 81 is 1 over 9. Domain, I'm going to do that again in blue. So for the domain, we're going to go ahead and set the input greater than 0. The only input that we have is x. So x is greater than 0. There's really nothing to solve for. That was the only input. The other input was an 81, so you can't do anything. There's not an x there. So the answer is x has to be greater than 0. So your only answer then is going to be x equals positive 1/9. It can't be the negative 1/9. The negative 1/9 should be thrown out. All right, part B, what happens when there's a constant? You're going to want to move all the logs onto one side and the constant term to the other. And then once again, you're going to do the same thing, isolate log and solve. Well, I guess isolate log and solve. Usually you're going to convert. So right now we have a log on the right side. I'm going to go ahead and move that to the left side. So log base 3, it's a minus on the right. So I'm going to add it to the left side. Oops, I forgot the input. X plus 19. So I'm going to say plus log base 3, x plus 1. And then I'm going to go ahead and say that that is going to be equal to 5. So again, all I did was I moved this over because I want the logs to be on the same side. Okay, so I added it over. Now I'm going to go ahead and Write it under 1 log. Because of the addition, that means I can be multiplying. And I'm stuck in log form, so I'm going to convert it. 3 to the 5th equals x plus 19 times x plus 1. I'm going to go ahead and multiply that out. 3 to the 5th is 243. I'm going to FOIL here, because remember, I want it equal to 0. So I'm going to subtract 243. That's going to get me minus 224. And then I'm going to factor it. Two numbers that multiply to negative 224 and add to 20 are positive 28 and negative 8. You probably have to use a calculator for that, which is fine to figure that out, just to try different multiples. And those are your two x's. Now we have to check with the domain I keep doing in blue. So the input has to be greater than 0. So x has to be greater than 19. And then we also have x plus 1 has to be greater than 0. So x is greater than negative 1. So those are our two things. So if x is greater than negative 19 and we need it to be greater than negative 1, where do they both overlap? That would be x is, or where, where do they both overlap? Which is x is greater than negative 1. You can't say x is greater than negative 19, because let's say the number was negative 18. Negative 18 is not greater than negative 1, so it wouldn't work. So it's actually the smallest of the numbers, the one you're going to want to go with. So now you're going to check x is greater than negative 1. Well, negative 28 is not greater than negative 1, and x equals 8 is. So we keep that. If you want to look at visually why I picked that one, this is negative 19, and this is negative 1. We're looking for numbers that are greater. You want where they overlap, okay? And that would be overlapping from x is greater than negative 1, okay? So if you visually make it easier to look at, go ahead and draw a little inequality sign, an inequality for you. All right, next one, same idea as the last one. You want to get all of your logs to one side. So I'm going to subtract log x minus 2 because it's positive, and I also want to move over that negative 2, so I'm going to add it. Then I need to go ahead and get it into 1 log. Since we're subtracting, that means I'm going to be dividing. So I'm going to convert it into 1 log. So x divided by x minus 2 equals 2. I'm stuck in log form, so I'm going to convert. The base is 10. 10 to the second equals x over x minus 2. And then 10 squared is going to give us 100 over x over x minus 2. I'm going to go ahead and cross multiply. If you want to put it over an imaginary 1, that's fine. But again, cross multiply here. You're going to get 100x minus 200. 1 times x is x. Again, I'm just solving, so I'm going to go ahead and I'm going to subtract 100x. That gives me negative 99x. I'm going to go ahead and divide by negative 99, and that's going to give me 200 over 99. So that's my x. Now I have to check it with my domain. I guess I did everything in blue this time. That's okay. The input has to be greater than 0. So x minus 2 is greater than 0. So one part gives us x is greater than 2. The other part, the input is just x. The other part is x is greater than 0. So where do those two overlap? Again, if you want to look at a picture, there's 0, there's 2. This is x is greater than 0. This is x is greater than 2. Where do they overlap at? X is greater than 2. So that's our domain. And when you check 200 over 99, it's just a little bit over 2. It's 2 point something. So that works. That's my solution. All right. We are going to just briefly talk about part D. So for part D, notice they all have logs. So what you would do is just convert it into 1 log on both sides. Since we're subtracting here, we'd be dividing. And then again, because they both have logs, those would cancel. So you'd be solving this equation here, okay? And then if you'd like extra practice, you can go ahead and do that. What's going to end up happening though is if when you solve, you're going to get x equals -1. So I'm kind of skipping the steps because I think we all know how to cross multiply and solve. The domain here, you'd have to set each part greater than 0. So you have x minus 5 is greater than 0, which means x is greater than 5. The next part, x plus 4 is greater than 0, so x is greater than -4. X is greater than 1, x is greater than -2. Again, that's all from the inputs that I pulled from here. Now, which one of those is the largest number? Because that's where they're all going to overlap, and that's going to be x is greater than 5. Notice when we did solve it, x equals -1, that is not greater than 5. So sometimes you will get an answer of no solution. Okay, so I just wanted to make sure you're aware of that. All right, let's keep rolling. So we're doing more solving, more solving. So here in this next one, these are in exponential form. So it's very similar to the log form. You want to isolate the exponential. And if you can't, and try to get the same base. If you can't get the same base, then you're going to change to log form and solve. Okay, so we're still going to be isolating, except instead of a log, you're isolating a base. And then if you can't get the same base, then you're going to change to log form and solve. So whenever you're stuck, change forms. So this very first one, this is a problem we have done already. You can get them to be the same base. 4 is the same thing as saying 2 squared. And then we have the x sign. 32 is the same thing as saying 2 to the 5th. Remember, when you have the same base, you can set your exponents equal to each other. So that was the first unit that we did. So 2x is equal to 5. So x equals 5/2, and you are all done. In part B, same idea. The goal is to get it to the same base. This is 3 to the 2x minus 1 equals 9/27. If I simplify that, I don't know why we didn't simplify it. 9/27 is 1/3. So I'm just going to, it's just normal math. So let's just change that to 1/3. Now, because the 3 is on the bottom, that's like saying 3 to the -1st. So once again, I got them to be the same base. And whenever they are the same base, they're both base 3, you can set the exponents equal to each other. So we've got 2x minus 1 equals -1. Add 1, 2x is equal to 0. Divide by 2, x is 0. Done. Okay. This next example, I'm going to go ahead and divide by 2 to both sides. I'm trying to isolate that law or that exponential. So 3 to the 4x equals 5/2. I cannot get 5/2 and 3 to be the same base. Not going to happen. When that occurs, you're going to go ahead and change into log form. So this is going to be log of 3 or log base 3 of 5/2 equals 4x. You might be like, well, how am I going to solve that? You're going to use a calculator. The goal is to divide by 4 because then we get the x alone. So if we divide by 4 to both sides, that gets you an answer of x is alone now equals exactly log base 3 of 5/2 over 4. That's your exact answer. Okay, how do we get the approximate answer? Yes, you can use your calculator. To get the approximate answer, you'd have to type in log 5/2. Remember, it's the large number divided by the small, log 3, and then divide that by 4. So x is approximately, when you type that on your calculator, going to give you about 0.2085. So we'll say about 0.21. It depends on how they ask, exact or approximate. All right, next one. We cannot get, not possible to get e and 8 to be the same base. When that happens, we're going to go ahead and isolate. We've already got the exponential isolated, so we're going to go ahead and convert it to log form. I'm going to use natural log. So this is going to be, if you use log form, it's the same thing if you wrote down log instead of natural log. Natural log of base e of 8 equals x minus 1. You don't even really need the e because remember, whenever you have a natural log, it automatically is a base e. To solve for x, I'm going to add 1 to both sides, and that's what I'm going to type in my calculator. This is the exact answer, the approximate. Make sure when you type it in, you use parentheses. And you should get about 3.08. And you're going to have working time in class and typing these in. So if it doesn't, something's going wrong in your calculator, you got to ask me. All right, last type is going to be still solving some exponentials. But this one is different because it's an exponential equals an exponential, okay? So this is different. Exponential is equal to an exponential. So that literally means there's going to be an exponent, notice, on both sides where the x is. So we're going to have to solve this differently. So for this one, you're going to have to take the log of both sides and solve. You might have to use log properties, you might have to distribute, you might have to combine. It just kind of depends on the problem. So let's go ahead and take a look. So again, we have x's in both of these in the exponents. So take log of both sides. So literally, you're going to add a log into both sides. It's okay to do that because we're doing it to both sides. Okay? Now we're going to use our log properties. Remember, when something is an exponent, you can swing it to the front. Same with this one. This is an exponent. We can swing it to the front and make it a product. So this is the same thing as saying x times log of 4 equals, I'm going to use parentheses around the 2x plus 1. That whole thing was the exponent, and I'm swinging the whole thing. Now, it says distribute if necessary. We are going to distribute because notice we are multiplying 2x to the log. So we're going to end up having 2x log of 3 and then plus 1. I'll make it look like a 1 log of 3. If you don't have the 1 there, that's fine. Now we have to get all the x's on one side. And I'm on step 4 if you're reading above. So notice that I'm going to subtract 2x log of 3. Why? Because I want this and this on the same side because they both have x's. So again, this is step 4. If you're looking above, this was distributing. This was step 3. This was step 2 and 1, if you're kind of looking at the steps above. Equals log 3. Now we're going to factor out an x. So if you want to think about this as step 5, I'm going to factor out the x. Notice that there is an x in both of these, here and here. So I pull that out, which leaves me with log 4 minus 2 log 3 equals log 3. I can get the x all by itself. You might be like, how? By dividing. You're going to divide this entire thing by log 4 minus 2 log 3, and you're going to do that to both sides. Log 4 minus 2 log 3. These cancel. So x equals exactly log 3 divided by log 4 minus 2 log 3. And you can type that on your calculator. Make sure you use parentheses around the denominator. And x is about negative 1.35. Again, you're going to have time to practice all this in your calculator. So if you don't get it when you're working on Math Excel during class time or the warm-up during class time, ask me so that I can show you in your calculator. But that's how you type it on in, because you have a log button on the left side. All right, next one. You can't get e and pi to be the same base. We're going to go ahead and take the log of each side, or I'm going to use natural log. It doesn't matter if you wrote log instead of natural log. We would end up with the same answer in the end. But I'm going to do natural log. So again, you literally just put a natural log in front of both problems. And then you're going to go ahead and solve. Recall that natural log e is just going to give you negative 4x. By simplifying this one, I'm going to go ahead and take my exponent here and swing it to the front. So this is going to be 1 plus 3x times natural log pi. So I'm going to go ahead then and distribute. So this is going to be negative 4x. I'm distributing 1 times natural pi is natural pi, and then plus 3x times natural pi. Same thing, I'm going to go ahead and get the x's on the same side. So I'm going to have to subtract 3x natural pi, and the 1 natural pi stays on the right side. So x is on one side, then you're going to factor out an x. And then the last step is to get the x alone. You're going to divide by this entire thing. And when you divide by that entire thing, you're going to get natural pi divided by negative 4 minus 3 natural log pi. You can type that exactly on your calculator. The only difference is make sure you put parentheses around the denominator because there's more than one thing going on. And that's going to be about negative 0.15. Okay. Really, C and D are exactly the same steps. So I would have had you practice this. They're both about, I'm going to put the answer here. So if you want extra practice, you can. This one's about 0.55. And if you solve this one's actually going to be exactly 0. So it's the same exact steps from above. And we'll do more in the warm-up in the Math Excel. But if you want even more practice, there is C and D. Okay, you have one question to answer after this, and it's going to be reflecting on the notes.